What's up everyone, Christian here. So today I'm starting a 2 to 3 part series on C++ and how you create a Hangman game inside of it. So typically the Hangman game can be done using strings in the string library, but if you're just starting with C++, you're kind of getting your feet wet, it's a really good practice for understanding how arrays work and how they iterate through. So that's what we're going to be doing today. We're going to be completing the game entirely using arrays and for loops essentially. So what are you going to be able to do by the end of this? We're going to be taking a user input and comparing it against a word that us, the creator, has already put into the system. So we can evolve it to eventually take user input, store that as the word, and then a second player comes and compares against that and plays against them. But for now, it's just a word we put into the system that is stored in an array, and then the user is going to be allowed 10 or so false guesses until they lose, or they're going to be allowed, obviously, to guess all the way through. If they get it right, they get the option to play again. Congratulations, you won, blah, blah, blah. Pretty basic hangman game. Again, the key with this is it's all arrays. We're doing array practice. We're going to really get familiar with how you work with an array, multiple in this case. So let's get started. As you can see here, I'm using C-Line. This is just the IDE I have at the moment for C++. So it starts off thinking that you might want to have a little intro stuff. That's great for us. That's fine. The one thing I do want to change with this is I'm going to be using namespace standard. To each their own. If you don't want to do that, I understand. I just happen to really enjoy not typing STD every single time. So I should say too, I'm kind of going with this tutorial series with the assumption that you have some C++ experience, that you're at least an intro into it, or you're trying to get more familiar with it. But I will structure it so that anything we're going to do here that I think is maybe beyond just the typical C out situation, I will try to explain and elaborate on. I try to keep these quick though. Alright, so the first thing we need to structure here is we need to store the user's word, the word that we want the player to be guessing. So to do that, we're actually going to construct an array, and each element in the array is going to be of type char. We're going to actually do every single letter broken down into the array. So we're going to go with char. We're going to call this the guess word. And I'm going to designate my word to be, let's see here, how large do I want to make it? We'll figure out afterwards. I'm going to make it the word YouTube. Alright, finally got to put it in there. Alright, so it's all lowercase, all together, so not the best representation of YouTube, but it'll work for our situation here. Now, the thing to remember with arrays is that I can, if I initialize it with and actually fill it with data, I don't need to pass it the size. It actually can figure that out on compile and count how many elements are in this array. Now, if you want to, that's fine. Otherwise, just you can do this and it's going to be great. We will need to know the size of our word in the end anyways, though, just how we do comparisons. So for now, I also want to have a way of tracking how many guesses the user's taken and what letters they've guessed, because if a user's going to guess W and that's wrong, but then they guess W again by accident, maybe they forgot or something happened, I don't want to penalize them for that. I want to inform them that they have already guessed that and allow them to guess again. So I'm going to store that in an array as well. So we're going to do a char array, call this past guesses. And that one is just going to be left empty. This one I do need to pass a size to though, obviously. So what I'm going to do here is I'm just going to pass it the number of guesses that I'm going to allow. So if I'm only ever going to allow them to, so I actually just thought about that. I'm not going to pass them, I'm not going to store them just the guesses, or the size of just the guesses that I'll allow. I'm actually going to allow them to guess the length of the word plus the guess size, the number of guesses. The reason for this is, let's say they guess YouTube up into the E, so they haven't guessed the E yet, and then they guess 7 more wrong digits. I don't want to not allow them to guess 7 and only let them guess 1, because that would have been 6. They guess 1 more, that's wrong. So I'm actually going to do the 7 characters that are in my guess word, plus let's give them 10 false guesses. So let's give them an array of 17. There are some better ways of doing that, and we can go back and clean that up, of course, but for now, I think just to get the logic under our belt, we're going to want to go with that. So the other thing too is I want to be able to display out the typical board, or how you would see it when you play Hangman with the dashes and everything. So the way I'm actually going to accomplish that is I'm going to build an array of dashes the same length of our guess word. And then as we iterate through, if there's a match on the guess, we're going to replace that specific dash at that indice with the letter, and then it'll slowly build up the actual Hangman board. So I'm going to do another char array. We'll call this the board. I'm going to just fill that. We can leave it empty. Or sorry, don't have to pass it to size, but I'm going to fill it with dashes that are underscore. I'm going to pass it 7 of these because that is the size of our word. So as we iterate through, we'll slowly fill those in with actual words. I'm also going to want to have a variable that stores the user input. So this is pretty typical. I'm going to name it a char. We're going to call it user input. Camel case. All right, we're going. Here we go. All right. So let's think about the next thing I'm going to need. So at this point, I've got the 3 arrays. I can store the word of choice, past guesses, and display how the board looks. I've got a variable for the user input. I also told you that I want to only allow for 10 false guesses. Well, that means that I'm probably going to need to keep track of how many false guesses they keep. So that's going to be an integer. We'll do wrong guesses. And then we are going to, I think that's going to be good for now. So we'll add some more variables as we go through the logic, but I think for now, that'll be okay. So first thing I want to do is I want to let them know that they're playing Hangman. So what I'm going to do here is I'm actually going to inform the user that I want them to take a guess. So we're going to tell them a letter. And then we're going to see in to the variable that we stored, which is user input. Okay. And at this point, we've got it. So now what do we want to do? So the first thing I want to do is I want to be able to take in uppercase and lowercase, just in case the user decides, hey, I'm going to try uppercase. The first thing I'm going to do is actually cast this down to a lowercase variable. So the way I'm going to do that is you actually do user input equals to, there's a built-in function in C++ to lower. And I'm just going to pass the name of the variable again. So this is just reassigning the whatever variable I took in as a lowercase version of itself. So the first thing I want to do is actually check if this is a valid guess. And so how am I going to do that? Well, I'm going to actually eventually turn this into a function, but for now we're going to build it into here. So I'm going to actually take this input, this char, and run down the list of the past guess array. And if there's ever a match, then this is not a valid guess, obviously. So what we're going to do is go and create a for loop. So initialize I to 0, and I'll walk through all this in case it's a little confuzzling in a second here. We're going to go through the, okay. I'm going to use the size of function, the built-ins, to get the size of my array. Obviously, this is why I said if we know that it is 17, we can just pass it 17. I want to make this a little more dynamic though, lets you actually change these arrays pretty easily, and the logic for the rest of the code will still hold up. So we're going to actually do with the past guesses, and then we're going to increment by 1. So what do we want to do? So I'm going to utilize the I as our indice count. So in the array, obviously they start at 0 and they jump up by 1. So if I wanted to get the U out of guess word, I would pass guess word and I'd give it a 2, 0, 1, 2, and that would return U. So I'm just going to use that same logic here, and I'm going to go through and say if the, let's do this, user input equals the past guesses at I. I'm going to put a little comment here and we'll come back and fill in some logic. not valid. This is not a valid guess if it matches at any point. So what am I going to do there? I'm actually going to see out to the user. Not a valid guess. Try again. Maybe we'll say already used. Okay, so the user now knows that they made a false guess. Well, what do I want to do? I'm going to want to actually have some sort of flag, some sort of register that tells me later in the code did I have a valid guess or not. So I'm actually going to use a boolean. So we'll come up here and we will actually make a bool of, let's call it solid guess, because it was a solid guess. Alright, so then we'll make solid guess equal to false. I'm going to, right here, I want to reset it, so actually, oops. Yeah, I'm going to reset it every single time. So I guess this will get fixed when we change these change these for loops into functions, but for now that's going to be session or video 2, but for now we're just going to do this. Solid guess equals true. So every time it comes through and checks the letter, I'm going to assume that it's a valid letter. The reason I can get away with this is because on its first time finding one, I'm just going to break out of this. And remember, break lets me actually exit this loop and then continue on down the line. So solid guess having been false, I can now do a comparison at the end and say if it was a valid guess, I can do the logic here. If solid guess, remember if you pass it nothing, it's just treating it like a boolean, 1 or 0, true or false. So it's saying if that is solid guess true, then I want to continue with the rest. Else we're going to have to wind up saying, all right, go ahead and go back up to the top and pick again. So we want to do a similar system here where we want to actually iterate through all the letters or elements inside of guess word array. So at this point we know that we have a valid guess, and now we're going to go through and check again. So I'm going to do another for loop, and just because it's right after 1, I kind of want to make it j equals 0 while j is less than or equal to, keep my style and syntax there, size of guess word. I just thought of something that I had forgotten to tell you on the past one. Fix it. Alright, so the one issue that we got with this is size of is currently going to return the actual how many elements are in an array. That's fine for us, except it's going to start at 1, 2, 3, 4, 5, 6, 7, go all the way to 7. But the last time we're going to hit 7, and we're actually going to be out of our array indices size. So because it starts at 0, when you actually index through these elements, 7 isn't appropriate. We want to just fix that by going up here for both of them and just minusing 1 off. And we're going to minus 1 off. There we go, that fixed it. That's going to keep us within our range of our actual array indices. So I want to do the same thing here. I want to go ahead and say if at any point the user input equals this time it's actually the guess word at element I, we want to do a couple things here actually. First thing we want to do is I'm going to tell the user congrats, that was a letter, if I can spell. Okay, the second thing I want to do is actually update the board. So right now the board's just sitting out at all blanks, but if I take that element, and so at this point right here, I know that, let's say I guessed U. It's going to iterate for the first two. It's not going to find anything. At the third one, at indice 2, so when I is 2, it's going to say, oh, hey, that matches. So I'm going to see out that. But now that I know that that U exists at position 2, I can actually update the board with the same variable. So I can do board I, indice 2, equals guess word I. And this isn't just going to allow us for a single letter, it's actually going to allow for duplicates. So let's say that on the second one, or it found it on indice 2, It's going to go to indice 3, not find it. Indice 4 is going to find it as well because I'm just iterating through this entire for loop and it's going to update that. So it'll automatically fill in these first 2 U's here. So that's pretty neat. So the next thing I want to do is see out the I'm going to see out the actual board variable. And there is a way we're going to go about adjusting this actually, because typically this isn't great practice. We can see out the board and it's going to show us the full word. But realistically, if we're utilizing arrays in this method, we might as well have a second or a third for loop that for every single indice in the array prints it out into a single line. It's just going to be a little cleaner. It's going to be something that, in my opinion, I would look at as a little more reliable. I'm not actually sure the circumstance that caused it, but sometimes this can actually just point to a space in memory and just print out the memory address of board instead of actually printing out board. I think it has to do with the compiler and the IDE. With C-line, this will work, and it might just be a C-line thing, but we will fix that. I'm just getting it through. I got to keep track of time here. We just got to move fast. So at this point, we've checked if we have a match. So again, just like in the guess word, if we've had guess in the past, I want to have a way of tracking this. So I'm actually going to utilize a Boolean. And let's separate these guys. We'll say match. So this one is actually interesting, or the reverse of guess. I want to default it, and remember we're going to fix this when we go to functions because there's no need to iterate over and reset it to false every single time like this. But for now, we'll assume it doesn't match. If it does, we'll say match equals true, and boom. So we've got a solid guess still. Make sure that we got everything. Alright, there's one more piece of logic we got to do, and that's if this was not an actual guess that's in the word. So, do an else statement. And the first thing we want to do is count this against one of their attempts. So, if this was a valid guess, but it wasn't one that's in our word, that's going to increment their guess counter. So, I'm going to use, what did I call that? Wrong guesses. We're going to increment wrong guesses by 1, shorthand, Trinity++, and then let's get the user output, let them know that wasn't valid. Snap. Alright, and then I think I also want to give them input as to, or output as to how many guesses they have left. So we're going to do the, this is where we need to go up here. So I currently am tracking how many guesses they've taken. I haven't tracked how many guesses they actually have. So this is going to be one of those things where we can either store it as like the max guesses you have is a certain size. And you know what, that's just what we're going to do actually. So right here with wrong guesses, I'm going to do int max guesses. And we're going to set that equal to 10. I want them to have 10 wrong guesses. I'm going to be pretty lenient. And we're just going to do the math in line. So max guesses minus, what do I call that? Right there, wrong guesses. See out that, and then say, actually right here, you have guesses left. Good luck. Cool. So that's actually iterating through, showing them how many guesses they have, and we are cooking. Alright. So actually what we're going to want to do is I'm going to edit this a little bit. Is instead of actually informing the user inside of the for loop, because what's going to happen here is every time they have, let's say you have duplicates, so U is in there twice, you're going to get congrats, it's a letter, congrats, it's a letter, and we are going to just give the user unneeded information. So I'm actually going to get rid of this. Actually, we'll do it right here. So what's going to happen here is solid guess, it's going to run its logic, and all I want to do at the match situation where it actually matches is I'm going to get rid of that. I realize I forgot a semicolon there anyways. I do want to update the board. That's fine. And I'm realizing I called these all I's when they should be J's because I'm utilizing J's here. If you caught that, congrats, good job. If not, come on, focus. Alright, so I do want to update the board, and I do want to set that the match flag, the Boolean in this case, is to be true. And that's pretty much all I want to do. I'm going to cut this out, delete that, and every time it iterates through, it's going to be false. That's fine, that'll work, I think. And now I want to see if after that whole loop ran, if I at all got a match. If I did, I'm going to give them some input. If I didn't at all, then I'm going to iterate through the guess. Because otherwise, if I'm doing every single time, I'm counting them off. If it's not a match, then out of those 7 letters, I had 5 that weren't a match. I'm going to give them 5 false guesses at that. I'm going to ding them 5 times. That's not what I want to do. So what I want to do is I want to check that flag that I just set. I want to see if match is true. Then I'm going to tell the user, okay, congrats, that was a letter. And then else. Now is when we want to actually do the wrong guess increment. So I'm just going to Control V back into there. All right. So let's go through this real quick, which added a lot. First thing we have is we're storing our 3 arrays. This is tracking the word we want them to be guessing, how many guess or what they've guessed in the past, and what the board currently looks like, the playboard. We've got the user input that we're storing as a char, how many wrong guesses they've taken, and the max guesses they're allowed. We've got 2 booleans, which I'm treating as kind of flags here that allow me to determine later in the code whether they had an actual guess that was valid or a match that they could actually utilize. So I'm not telling them what they want to run, taking in the user input, casting it to lower. I'm just going to deal with all lowercase. You can do this to upper if you want. Just got to change your array up here to upper probably. Would be a good fit for that. I'm going to pass through, I'm going to iterate through every single element inside of the past guesses array. So obviously the first guess is going to be empty, but that's okay. It's going to be 17 empty places. We're fine with that. And I'm going to assume that each one is true at the beginning. If it's not, I'm going to pass false. And as soon as I get one false, I'm going to break because I don't need to check all the rest if I know that there's at least one guess I've already made. I mean, there wouldn't be any more, obviously. If I guessed A, it's only the way we have our logic here, it's only going to store A once. I am realizing that I do need to add that to our past guesses, though. So we're going to do, what did I call it though? Oh, past guesses. Past guesses. And I need to get it into the array, the user input. But I need to know where to put it into the array. So the way I'm actually going to do this is, I think, okay, sorry about that. So I think actually what we're going to do here is there's definitely a better way to do this logically. But I think what I want to do is actually track not just wrong guesses, but track just overall guesses in general. Because of how I want to actually go and iterate through it, I'm going to actually use the guess counter as the indice value that I can store into my past guesses. Essentially the reasoning for this is I can store all the wrong guesses, and that's fine, but I want to tell the user that they've already guessed you, even if it's a valid character that they can clearly see. Why a user would see that and guess you again, I don't know. But I definitely want to at least inform them that, hey, you already guessed this. So I think we're going to do another integer here. I'm going to put this one right here. Int. I'll just call it overall guesses. I might come back and fix this on part 2. I'm not a huge fan of how we're about to do this, but it will at least work for getting this rolling. So we're going to say that, now I need to know when to increment that. So I want to increment that on any guess. So we're just going to do it right after we cast the input. We're going to say overall guesses plus plus. So we're going to start it out at, I should actually initialize that to be 0. I don't want it to be a random thing in case. So we've got a 0. After the first guess, we are, I actually want to iterate that lower. Sorry guys. I actually want to iterate that once I am confirmed that it was a solid guess or not right here. So I'm going to go guesses and do it right below that. Okay, so starting at 0, I've got the past guess. If it was a solid guess, I'm going to put into the user input. This is essentially, I'm not going to try to store a second invalid guess of the same letter. So this will ensure that we store the same valid letter, that we store a past guess only if it's not currently already in the past guess array. We're going to rate the indices, the counter, so that we can go up to 1, 2, 3. And we'll have our logic in here that stores and says, okay, we're only going to go up to our past guesses being 17. And this should be ready to test here. Oh, I know what I want to do. I want to output the board as well. So we're going to see out at the very beginning the board looks like for the user, so they can see how many letters you have and all that jazz. I'm sure there's something that's going to break here, but let's just give it a runsies. Please guess a letter. Let's guess J. Alright, and we exited. So, what happened there? That's fine, but it did tell us snap is not a word. You have, our logic there is false for that. Let's fix that real quick. Max guesses being 10. Right here, right after we check if it was a solid guess, I just still want to increment my, what do I call the bad guesses? Wrong guesses by 1. There we go. But right here, I'll snap. Oh, I should initialize this to 0. Let's give it a try again. Cool. I have 9 guesses left. Good luck. So let's run it again, and this time guess when it's actually in it. Look at that. So there's a little issue with the logic of how it's outputting the board, but it did. You can tell it failed 2 of them. And then we also have an issue with our logic because it's still getting to the snap. So if match. Yes. It's right here. Because we actually don't want to be doing that in the side of the for loop, because by the time it gets to the last indice, it's going to set to false, but it's never going to get inside this if loop and get to true. So let's run that again, and again, that's one of those things that we'll fix with the function, because we're going to return true or false from the secondary function. So let's try U. Yep, that was a letter. Alright, so why is our board printing out like that? Where's the first one coming from? Oh, duh. I still have that in there. I only want to print board. Sorry, see out the board. If it was valid at the very end. Cool. Come on. Let's run it. Boom. Alright, next thing here is let's fix this issue with it only running once. So what are we going to do? We're actually going to trap the, we're going to run this thing forever and just compare against 2 situations. One is that we've used up our max guesses, that we need to end the game. Or is that the users completely guessed the word correctly. So we're going to do a while loop, and the conditional for the while is going to be one of those 2. We're going to go with the easier of the 2 to compare in a while loop, and that's going to be that they haven't hit their max amount of guesses. So we are going to start here because I want the user to take input. So we're going to wrap this in a while loop, and I will fill that out in a second here. Get rid of that guy and bring it down to the bottom. Alright, so there's that. So alright, so there's that. So we are actually going to now fill in the conditional. So the while is going to be wrong guesses is less than the max guesses. So let's see here. Let's rerun this and see that we can actually guess multiple times. So let's guess G. It's not a word. You have 9 left. Let's just throw a bunch that aren't going to be in there. Cool. So I got all the way down to 2, and then less than or equal to. And for debugging purposes, let's change this to 4. I don't want to guess 10 times every single time. Oh, that's one's in there. 3 guesses left. 2 guesses left. 1 guess left. 0 guesses left. And then I need to actually get out. What is going on? I'm decrementing that variable in the wrong place, obviously. Just where? I'm incrementing it twice. That's me being very silly. It's a solid guess. I don't care about that. That's my bad. If it's a match versus not a match, that's what I want to actually do. The solid guess. Yeah, there we go. Okay. That's the thing about programming. It's, I don't care how long you've been doing it. It takes time to do it right. Just guess I, N, J, this should. Is that supposed to be less than this whole time? Let's see. It's going to hit 3. No, this shouldn't be. But let's just give it a college try here. Yeah, actually that was less than. And that makes sense actually, because the way we were incrementing our variable, if we had it at equal to, it would allow for 1 extra guess, and then by the time it's done with that, the logic is going to say, hey, you had 1 less guess that you should have had. Alright, my bad guys. So, we currently have a the core of a Hangman game going. So, let us go ahead and actually run it again, and this time we're actually going to guess the right thing. I'm going to guess you. Obviously, it downcasted as a lowercase, single at a time. We're going to assume the user can actually follow a prompt, and we're not going to try to deal with multiple. Boom. So obviously the letter's done, and we're still allowed to guess, but that is logic we will fix in a second. Probably actually the second part, now that I'm realizing how long this video is going to get. So let's test the functionality of, we already guessed it. So we just guessed an M. Let's check it again. So M, not a valid guess. We tried it. You still have 2 guesses left. Oh, so we need to fix the fact that it decremented the, or incremented how many false guesses we've had. But that is something we can quickly do. Let's see where we did that. So not a valid guess. Solid false. Yes, we actually want to, what's happening here is we're running the if statement. This is a fat fingered issue on my part, is we're running the if statement on, was it a solid guess, is it a valid guess? And we're going through and we're checking, is that word actually, is that letter actually anywhere in the word? I'm coming out here and saying if it is, then go ahead and say, hey, that's a word. If not, add the wrong guess, print this out. The problem here is the way we're handling this is we're going through every single word, if solid guess, or every single letter in the word, if solid guess was true. Well, because it's valid, solid guess is false, or was not valid, solid guess was false. That's fine. It's going to skip over this, but it's still going to come down to here and say, is match true? Well, we default match to be false. Actually, I guess we don't default it to be anything, but it should be. It's always good to initialize your variables with the right type, with the what you want them to start off as. So, match is false, and then it actually means I can get rid of false there. I don't know what I was thinking with that. Then, if it's false, we're actually gonna come through here and jump into this guy. So, how do we want to avoid that? Well, actually, you just want to include those 2 if-else's inside of the overarching if of was it a good guess? Because we only care about this stuff if we know already that it was a valid guess. So I'm sure there's something going on here, but let's double check. Yeah, that's valid. Yep. And then we'll check tube. Okay. Let's check when it is in there. H. Aha. We are somehow saying that that is still solid. I'm being dumb. This needs to be in here still. Still needs to reinitialize, reset to false. Whoops, a daisy. Let's retry this. I did know something else there with the H that the second time I ran through, and that makes sense. Alright, it's not a letter. You have 3 guesses left. Try it again. Okay. Look at that. We are cooking with fire now. And then obviously it should stop right there. We'll add that logic second part. But let's see. Let's try you again. Not a valid guess. You already used it. Because obviously we put it into YouTube. Let's try D. I think that was. Yep, and that was our last guess. Alright, guys. So that is some pretty basic fundamental knowledge on arrays and how to iterate through them and how we can build a Hangman game that is reliant entirely on array iteration and not on string comparison, which is just doing the same thing in the background, but when you're really trying to get in depth and kind of learn how to do all this, it's important to do it on your own and kind of do it from the ground up. So that's just how you become a better programmer. I apologize for some of the length of the video and some of the mishaps, but that's programming. So we're going to do part 2. Part 2, we're going to add in the logic for when the user actually wins the game, when the board matches the output array. Feel free to go ahead and jump ahead and try that. And we're also going to add the, we're going to take basically these for loops and the just kind of the conditional logic on the flags and put them into their own functions, make them function, do it properly with our own header and our own actual file, and able to return true or false. We'll do some Boolean functions there. And then the third part, we'll actually add some graphics, and that one's going to be pretty cool. We'll actually have the whole Hangman guy. So I will see you in part 2. Thanks for sticking around. Bye!